So if you draw the free body diagram, let us say we are applying a force at an angle theta, let us say. So mg is downwards, normal force upwards, and f also like resolved into two components, f cos theta, f sin theta. So we started this problem and that meeting was ended. F is the force applied at an angle theta. So since there is no vertical motion, so net vertical force is 0. So let us see in vertical forces. If we write n plus f sin theta, n plus f sin theta upward direction minus mg, mg is downward direction. So n is equal to normal force formula. You will get it as mg minus f sin theta. And if you write along the horizontal net force equation, before limiting friction, since no motion is there, before limiting friction, no motion. Okay, so that is rightward direction f cos theta, leftward direction mu n. So mu n minus f cos theta, mu n minus f cos theta is equal to 0. A normal force you substitute mu of mg minus f sin theta minus f cos theta, which is equal to 0. You have to simplify like this. You have to simplify and you have to get the f equation. Please do this. You have to practice it now. If you do horizontal forces and substitute normal force value, you will get f is equal to mu mg by mu sin theta plus cos theta, or cos theta plus mu sin theta. Okay, but in the question, what they have asked, what minimum force is needed to slide the block? Okay, and in which direction? Minimum force. So minimum force means F should be minimum, means the denominator should be maximum. Mu sin theta plus cos theta should be maximum. So maximum condition, if you apply differentiation, derivative of mu sin theta plus cos theta to be 0. So we know that maximum and minimum condition, that is derivative of that particular thing, should be 0. Okay. So d by d theta of mu sin theta plus cos theta is equal to 0. You apply derivation principles. Sin theta derivative cos theta derivative minus sin theta. Okay. So from here, theta is equal to tan inverse of mu. Theta is equal to tan inverse of mu. So you got angle, you got force also. This is the magnitude of the force to be applied, and this is the angle at which angle to be applied, that is theta is equal to tan inverse mu. But further simplification, if you do into cos theta by cos theta, if you do further simplification, since answer is not matching, mu mg by cos theta by mu sin theta plus cos theta by cos theta, which is equal to mu mg sec theta mu tan theta plus 1. Okay, Again mu is actually we got tan theta. Mu tan theta we got here. Mu is equal to tan theta. So if you substitute here, mu mg sec theta by 1 plus tan square theta. 1 plus tan square theta is nothing but sec square theta. So sec theta gets cancelled. So the F minimum to be applied is mu mg by square root of 1 plus tan square theta. Sec theta is nothing but square root of 1 plus tan square theta, or mu mg by square root of 1 plus mu square. Okay. And to be applied at an angle theta is equal to tan inverse mu. The force to be applied is mu mg by square root of 1 plus mu square, and at an angle theta is tan inverse mu. Okay. Next problem. 21. The friction coefficient between the board and the floor shown in figure is mu. Find the maximum force that the man can exert on the rope so that board does not slip on the floor. So man has to apply the force, and we have to find out that force so that the board does not slip on each other. Board is that small m. Okay. So basically you have to find out the tension force. The force to be applied. So for the man, free body diagram. Normal force upwards, tension upwards, m1g downwards. So from here, vertical forces if you take, vertical net force if you take, that is N1. Actually, you take it as N1. N1 is M1G minus T. N1 as M1G minus T. And for the small m block, I am taking it as M2 mass. And for M2 mass, upwards N2, downwards N1 by man. Okay. And downwards weight, its weight. And if you see here, rightwards there is a rope. So tension is rightwards. Frictional force will be leftwards. So frictional force I have written left, tension right. And here vertical forces if you consider N2 is equal to N1 plus M2G. And horizontal forces if you consider T is equal to mu N2. T is equal to T minus mu N2 is equal to 0. N2 is nothing but N1 plus M2G, that is M1 plus M2 into G. So normal force will be man mass you have to consider, and that man mass you have to consider, and also this board mass you have to consider. That will become M1 plus M2. So tension force you have to find out. That is what the given question. You have to simplify this. Okay. A 2 kg block is placed over a 4 kg block and both are placed on smooth horizontal surface, the coefficient of friction between the blocks is 0.2, and find the acceleration of two blocks if a horizontal force of 12 Newton is applied to the upper block and to the lower block. So this is the diagram actually. So 2 kg block is there, 4 kg block is there, and friction between the two blocks is 0.2. They have given friction coefficient, and it is placed on a smooth horizontal surface. So here smooth surface. So what we have to find out? If 12 Newton force is applied on the upper block, find the acceleration of two blocks. You have to find out the acceleration of the two blocks. Okay. If 12 Newton force is applied on the upper block. So that is first problem. So 12 Newton is applied on the upper block. Then free body diagram. If you draw normal force upwards, weight downwards, 12 Newton rightwards, frictional force is leftwards. Frictional force is mu into N1, okay. So normal force is mg, that is 20 Newton. Frictional force will be 0.2 into normal force, that is 2 Newton. So leftwards frictional force is 2 Newton and rightwards applied force is 12 Newton. Not 2 Newton, I think. 20 into 0.2, 4 Newton. 4 Newton. Okay. So net force on the block is 12 Newton rightwards. Frictional force leftwards 4 Newton. That gives you 8 Newton. Once you get the net force by mass gives you acceleration. Net force by mass gives you acceleration. Okay. So simple only, you have to draw free body diagrams, that's it. That gives you the answers. For the 4 kg block, important point to be noted is, if you draw the free body diagram, two weights are acting, 2 kg, 4 kg. But in the frictional force expression, we will not take the 4 kg weight in that normal force expression. Why? Because 4 kg kept on the smooth surface. That is very, very, very important point. Okay. And so the frictional force between the 2 kg and 4 kg block only will act as a applied force on 4 kg block. Frictional force between the 2 kg and 4 kg will act as a applied force on the 4 kg block. So net force is on the 4 kg block is just a frictional force between the two blocks, and from there you can find out the acceleration of the 4 kg block. The answer you get is 1 meter per second square. Very good. And in the case 2, if you think about, this is the situation. So 12 Newton they are applying on the 4 kg block. In the previous case they were applied on 2 kg and 12 Newton is applied on 4 kg. Then what will be the acceleration of the two blocks? So vertically normal force for 2 kg block is 20 Newton, and horizontal forces, like if you consider, there will only be frictional force will be there. per 2 kg block, and that frictional force only applied force. Yeah. Find out acceleration. A1. Draw the diagram quickly. Find out A1. Find out mu value, find out M1, find out substitute M1, substitute mu, substitute N1, and you will get A1. Huh? You are getting A1 as?
Sir, 2 meter per second.
Okay, good, very good. And for 4 kg block, 4 kg block, this is the free body diagram and net force equation. A1 is you are getting 2 meter per second square, and also find out A2.
A2 also 2, sir. 2 meter per second, sir.
2, huh?
Yes, sir.
All of you, are you getting 2 only? Okay, good. Very good. Okay.
Yes, sir, 2 only, sir.
Yeah, that is the answers. The next 23rd. Find the acceleration A1, A2, A3 of the 3 blocks. So previous problem 2 blocks. They have given in this 3 blocks. If the horizontal force of 10 Newton is applied on 2 kg, 3 kg, 7 kg. Okay. So again, you have to draw free body diagram for each block, and you have to find out net force equation. Then you have to find out acceleration. So very, very important. Beta, here we will be learning many concepts here. So in between 2 kg and 3 kg, mu1 is 0.2. In between 3 kg and 7 kg, mu2 is 0.3. In between 7 kg and floor, that is smooth surface. Okay. So 10 Newton is applied on 2 kg. 10 Newton is applied on 2 kg. So normal force upwards, weight downwards, 10 Newton rightwards, frictional force leftwards. So frictional force is mu into N1, which is 0.2 into 2 into 10, 4 Newton. So net force will be 10 Newton rightwards, 4 Newton leftwards. Net force is 6 Newton. So acceleration of the 2 kg block is net force by mass, meter per second. Okay. 10 Newton rightwards, 6 Newton, 4 Newton leftwards. So net force is 6 Newton. 6 Newton by 2 kg mass gives you acceleration. Here, in between 2 kg and 3 kg, there is a frictional force 4 Newton leftwards, and that 4 Newton only will act as a applied force on 3 kg. Okay. But in order to move 3 kg plus 2 kg, the force required is, that is limiting frictional force required is mu2 into m2 plus m1 plus m2 into g. Okay. Actually, you are not applying any force on the 3 kg. You are applying a force of 10. What they have given? You are applying a force of 12 Newton on 2 kg. There is a friction between 2 kg and 3 kg, and that is 4 Newton. 4 Newton leftwards, and that 4 Newton only will acting as a applied force on 3 kg. So let us see whether this 4 Newton is crossing the limiting frictional force or not. Okay. So if you see here, limiting frictional force to move the body, 3 kg body, is 15 Newton is required, because limiting friction is mu into normal force. Normal force is 3 kg and 2 kg. Both you have to consider 5 kg. So if you do mu2 into m1 plus m2 into g, that is 0.3 into 5 into 10, that is 15 Newton is required. So 3 kg won't move relative to 7 kg. Why? Since limiting frictional force is less than applied force 4 Newton. Okay. So that's why, since 7k in between 7 kg and surface, they are smooth. So that's why 7 kg and 3 kg will move with the will have same acceleration, will move with the effect of 4 Newton on the 3 kg will not be there, but since 7 kg is on the smooth surface, so 7 kg and 3 kg will slip because of that 4 Newton. Will have the same acceleration, will move together, and that 7 kg 3 kg acceleration is A2 is equal to A3 is equal to force. Net force is 4 Newton by mass, total mass, that is 4 by 10 is equal to 0.4. Okay. Did you understand? Please, any doubts are there, please let me know. Next part is the force is applied on 3 kg block. The force is applied on 3 kg block. So if you try to see the forces of each block on 3 kg 10 Newton, because of friction between 2 kg and 3 kg 4 Newton left side, and 3 plus 2 kg and 7 kg friction force is 15 Newton left side, 15 Newton, 15 Newton, that we have already calculated here. Okay. But we have already calculated here. 15 Newton. Okay. So in between 3 plus 2, 5 kg and 7 kg, 15 Newton. In between 2 kg and 3 kg, 4 Newton leftwards. These two forces are acting leftwards. And you are applying a 10 Newton rightwards. Okay. So total frictional force is 19 and it cannot move relative to 2 kg and 7 kg because frictional force is more than your applied force. So since 7 kg block is kept on the smooth surface, then again all the blocks will move together because of that 10 Newton force. Moving relative to each other is different and all the blocks moving together is different. Okay. Moving with relative to each other. Relative to each other means, for example, 3 kg will have to move rightwards, then 2 kg, 7 kg will move leftwards, something like that. All the blocks motion will be different. That is called, in that case, we say relative. And if all the blocks are moving, that in that case, we will not say relative. So all the 3 blocks move together actually. Why? Because since third block is kept on the smooth surface. Very, very, very important. Third block is kept on the smooth surface. That is important. Okay. So now again, acceleration of each block, if you consider A1 is equal to A2 is equal to A3, that is net force by total mass. Okay. And third case, on 7 kg you are applying. On 7 kg you are applying 12 Newton. 12 Newton or 10 Newton? I think 10 Newton. 10 Newton, sorry. On 7 kg you are applying, third problem. Then in that case also, it is same as B. All the blocks move together. Okay. So it will move with a 5/6 meter per second square acceleration. Please tell me if any